Okay, Pre-Calc, this is our last lesson for the year, and then all you have is your study guide and your test. So we talked about this a little bit last year. It's going to be a little labor intensive, but it isn't really hard, so just stick with me. Okay, we're going to start by talking about Pascal's triangle. And Pascal's triangle is here. I have the first four rows, because we talk about row 0. And each number in Pascal's triangle is the sum of the two numbers diagonally above it. And all the outside numbers are 1. So the next row is going to be a 1, and then we're going to say 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then a 1. And then the next one, we start with 1, and we get 5, 10, 10, 5, 1. So these are row 4 and row 5. So you can notice some things about this. First of all, it's symmetrical. There's 1s on all the outside, and the number after the 1 is the row number. So like row 2 has a 2 here, row 3 has a 3, row 4 has a 4, row 5 has a 5, and so on. Okay? So we're going to use these numbers in Pascal's triangle for binomial expansion. So let's look at the next part where it talks about binomial expansion patterns, and they are all written out there for you. I'm not going to write them all out. A plus b to the 0 is 1. A plus b to the 1 is just a plus b, and then a plus b squared, you would FOIL that out. You would get a squared plus 2ab plus b squared, and then so on there. Those are all FOILed out. So what do you notice about the coefficients? Well, first of all, they're symmetrical, and they form the nth row of Pascal's triangle. So if you look at a plus b squared equals a squared plus 2ab plus b squared, the coefficients are 1, 2, 1. Which is this row of Pascal's triangle, which is row 2, which corresponds to that. And if you look at a plus b cubed, you get a cubed plus 3a squared b plus 3ab squared plus b cubed, and the coefficients are 1, 3, 3, 1, which are these, which is row 3, which corresponds to that. And the rest are all the same too. So what do you notice about the coefficients? The coefficients are symmetrical and form the nth row of Pascal's triangle. Okay, other important patterns in the binomial expansion of a plus b to the n. A plus b to the n, some things that you should notice. The total number of terms is n plus 1. Okay, let's go back up here and look for a minute. Here, n is 2, and there are 1, 2, 3 terms. Here, n is 3, there are 1, 2, 3, 4 terms. There's always one more term. Okay, the next one, the first term is 1, and the last term is 1 because of these in Pascal's triangle. Okay, the next thing is the exponent of a decreases by 1 from left to right. So let's look up here. We've got a squared, a1, a to the 0. A cubed, a squared, a to the 1, a to the 0. Goes down by 1, and the exponent of b increases by 1 from left to right. So same thing. Look at the exponent of b, to the 0, b to the 1, b squared, b 0, b1, b squared, b cubed. the exponent of b goes up, and the sum of the exponents is always n. Okay, if you look at the sum of the exponents, like let's look at this term right here. Here's a to the first, b to the first. 1 plus 1 is 2 equals this. Let's look down here. We got a squared, b1, 2 plus 1 is 3, 1 plus 2 is 3, 3 plus 0 is 3, and so on. It's always going to equal 1. So we can use Pascal's triangle to expand each binomial. Let's look at some examples here. Okay, for number 1, we've got a plus b to the 6th. So we need the 6th row of Pascal's triangle. Looking back here, we don't have the 6th row. It would be 1, 6, 15, 20, 15, 6, 1. So the row 6 is 1, 6, 15, 20, 15, 6, 1. So because there's a 6 here, we're going to have 7 terms, 1, 2, 3, 4, 5, 6, 7. And to expand this, we're going to use these coefficients. So we're going to say 1, a to the 6th, b to the 0, plus 6, a to the 5th, b to the 1, plus 15, a to the 4th, b squared, plus 20, a cubed, b cubed, plus 15, a squared, b to the 4th, plus 6, a to the 1st, b to the 5th, plus 1, a to the 0, b to the 6th. Okay, I'm just writing every single term out so that you can see it. So look, the coefficients correspond to this. 1, 6, 15, 20, 15, 6, 1. And the exponents of 6 of a start at 6 and go down. 6, 5, 4, 3, 2, 1, 0. The exponents of b start at 0 and go up. 0, 1, 2, 3, 4, 5, 6. So if we simplify this, it becomes a to the 6th plus 6, a to the 5th, b, plus 15, a to the 4th, b squared, plus 20, a cubed, b cubed, plus 15, a squared, b to the 4th, plus 6, ab to the 5th, plus b to the 6th. And that would be your answer. That is in simplified form. All right, let's look at number 2. Number 2 is going to be a little bit different because we don't just have an a and a b, we have an x and a 2, and it's to the 7th. So we need row 7, and row 7 is 1, 7, 21, 50, not 50, I don't know why I wrote 50, 35, 35, 21, 7, and 1. So there should be 8 terms, 1, 2, 3, 4, 5, 6, 7, 8. And now we're going to expand this, and we're going to say 1, x to the 7th, 2 to the 0, plus 7, x to the 6th, 2 to the 1, plus 21, x to the 5th, 2 to the 2nd, plus 35, x to the 4th, 2 cubed, plus 35, x cubed, 2 to the 4th, plus 21, x squared, 2 to the 5th, plus 7, x to the 1, 2 to the 6th, plus 1, x to the 0, 2 to the 7th. And now this one, we actually have to simplify it because 2 squared is 4. So we would multiply that 4 times this 21, since they're not just they're not just variables. So let's simplify. This becomes x to the 7th plus, then we have to do 7 times 2. So it'd be 14 x to the 6th plus 84x to the 5th plus 280x to the 4th plus 560x cubed plus 672x squared plus 448x plus 128. And that would be our answer. Okay, so up here for number 1, we just had an A and a B. So it's pretty simple. So you can see all the coefficients. Here, because one of ours was a 2, you can't see the coefficients, the 1, 7, 21, 35, and so on, because we put 2's in there too. And now let's look at number 3. And number 3, we have a variable mixed with a number. We have 3m minus 1 to the 4th. So this one has a couple things. We've got a 3 and an m, and we have a negative here. So let's see what all that happens. So we need our 4th row, which is 1, 4, 6, 4, 1. And we're going to say this equals 1 times 3m to the 4th times negative 1 to the 0. And we have 4 times 3m cubed and negative 1 squared to the 1 plus 6 times 3m squared times negative 1 squared plus 4 times 3m to the 1 negative 1 cubed plus 1 times 3m to the 0 negative 1 to the 4th. So now let's simplify this. This right here simplifies. Remember that because there's parentheses here, this is 3 to the 4th and m to the 4th. So 3 to the 4th is 81 m to the 4th. And here we've got a 4 times 3 cubed. So that's going to be 108, but then we have negative 1 to the 1st power, so that's going to be negative 108 m cubed. And here we have 3 squared, 9 times 6 is 54, negative 1 squared is positive 1, so we have plus 54 m squared. Right here we have 4 times 3, which is 12, but negative 1 cubed is negative 1, so it's going to be minus 12 m. And then here we have negative 1 to the 4th, which is plus 1. And that is going to be our answer. So when you have a negative right here, when it's a minus, they're just going to go back and forth between positive and negative. You're going to start with a positive, and then it's going to be negative, positive, negative, positive. So you don't even really have to worry about that, like negative 1 to the 1st, negative 1 squared. You can just flip it back and forth, positive, negative, positive, negative. All right, let's look at number 4. We've got, now we have both of them with a number and a variable. 4c minus 3d, go to the 5th. I thought it said cubed. Okay, so we need the 5th row, which is 1, 5, 10, 5, 1. Whoops, I left a 10 out. Okay, remember it has to have 6 terms, 1, 2, 3, 4, 5, 6. And let's just go ahead and fill it in. So we have 1 times 4c to the 5th, negative 3d to the 0, plus 5, 4c to the 4th, negative 3d to the 1, plus 10 times 4c cubed, negative 3d squared, plus 10, 4c squared, negative 3d cubed, plus 5, 4c to the 1st, negative 3d to the 4th, plus 1 times 4c to the 0, negative 3d to the 5th. So let's go ahead and simplify this and see what it becomes. It's going to be some really big numbers because this is going to be 4 to the 5th. So this becomes 1024c to the 5th, and then a minus because of this. So then this becomes 3840c to the 4th d plus 5760c cubed d squared plus, oh, that one's got to be minus 4320c squared d cubed plus, I'm going to go downhill here, 1620c d to the 4th minus 243 d to the 5th. And that is the answer. All right, let's look at the next two, 5 and 6. These are going to be a little bit tricky. Okay, we got 5. Let's see. 1 plus 2 over x cubed. And row 3 is 1, 3, 3, 1. So let's see what we've got. We've got 1 times 1 cubed times 2 over x to the 0 plus 3 times 1 squared times 2 over x to the 1 plus 3 times 1 to the 1st times 2 over x squared plus 1 times 1 to the 0 times 2 over x cubed. And let's simplify this. This is just 1, so this just becomes 1 plus 3 times 2, 6 over x plus 12 over x squared plus 8 over x cubed. And that's going to be your answer, right? Same with number 6. It's the same type of thing, a minus 1 over a to the 6th. And we're going to use row 6, which is 1, 6, 15, 20, 15, 6, 1. So filling all those in, we've got 1 times a to the 6th times negative 1 over a to the 0 plus 6 times a to the 5th times negative 1 over a to the 1 plus 15 a to the 4th negative 1 over a squared plus 20 a cubed negative 1 over a cubed plus 15 a squared negative 1 over a to the 4th plus 6 a to the 1st negative 1 over a to the 5th plus 1 a to the 0 negative 1 over a to the 5th or 6th. So now we got to simplify this. This term right here simplifies to a to the 6th. And then this term right here simplifies to minus 6a to the 4th, because let's look at it for a minute. This is 6a to the 5th over negative a. So one of those a's are going to cancel and you get 6a to the 4th. This one right here simplifies to 15a to the 4th over a squared. So that's going to be plus 15a squared. And then this one is 20a cubed over a cubed, but it's negative. So those are going to cancel, and it's just going to be minus 20. And then this one is 15a squared over a to the 4th. So those are going to cancel, and we're going to get plus 15 over a squared. And then this one is 6a over a to the 5th, negative, so that's going to cancel. And we get negative 6 over a to the 4th. And this last one here is just going to be 1 over a to the 6th. And that is the answer. That one was kind of tricky. All right, so let's look at there's another part to this. We can find, I don't know why I keep doing that. We can find any element. Maybe we don't need to have the whole binomial expansion. We just need to have one term. So each element of Pascal's triangle is assigned a row n and an element r. Note that both rows and elements begin with 0. Okay, so look at that picture over there on the side. The nth row, rth element of Pascal's triangle is denoted as nr, and it's defined as a combination. Remember when we did those last year? You can do that on your calculator. It is n factorial over r factorial times n minus r factorial. But you should have this button on your calculator that you can use your calculator to find it, as long as you know what row and what element. So let's look at some examples here. Number 1, the 6th row, 3rd element of Pascal's triangle is going to be 6 factorial over 3 factorial times 3 factorial, and that equals 20. Number 2, the 13th row, the 5th element, do this on your calculator, you should get 1287. Number 3 should be 153, and number 4 should be this. Now, one of the reasons that we want to use this instead of just looking back at Pascal's triangle, because what if we do need this, something like this? I don't want to write out 25 rows of Pascal's triangle. That's just going to take a really long time. So if we look at the next part, it says the r plus 1 to the nth, no, not to the nth, the r plus 1 term in the binomial expansion of a plus b to the n is the combination of n things taken r at a time, and then a to the n minus r and b to the r. Okay, so let's say you wanted, well, let's look at an example. Okay, number 5. We've got a plus b to the 10th, and we want to find the 8th term. So n equals 10 and r equals 7, because look, it's r plus 1. So r plus 1 equals 8, so r equals 7. R equals the term minus 1. So this 8th term is going to equal the combination 10, 7, a to the 10 minus 7, b to the 7. And then you're going to do this on your calculator, and this is going to give you 120 a cubed b to the 7th. And that's your answer. Okay, not too hard, right? Let's look at number 6. We've got x minus 7 to the 12th, and we're looking for the 3rd term. So n equals 12, and r equals 3 plus 1, which is, no, 3 minus 1, which is 2. So we're going to say 12 things taken 2 at a time, x to the 12 minus 2, negative 7 to the 2. Okay, this right here is this minus this, and this equals this. And you're going to put this in your calculator and find this, and you're going to get 3234x to the 10th. Because you've got to do -7 squared, that's going to be 49. And then you're going to find whatever this is on your calculator and multiply that, and it's going to equal 3,234. All right, let's look at number 7. P minus Q to the 8th. And we're looking for the 5th term. So n equals 8, and r equals 5 minus 1, which is 4. So we're going to say 8, 4, p to the 8 minus 4, negative q to the 4th. Okay, and you do this on your calculator, and you will get 70, p to the 4th, q to the 4th. Because this is an even number, the negative isn't there. All right, let's look at number 8. We've got 2k plus 1 to the 10th, and we're looking for the 6th term. So n equals 10, r equals 6 minus 1, which is 5. So we have 10, 5, 2k to the 10 minus 5, and 1 to the 5th. So you're going to do this, find what this number is, and then this is going to be 2 to the 5th that you have to multiply that by. So you'll get 8,064k to the 5th, because this right here is just 1. That's number 8. Let's look at number 9. We've got v plus 3 to the 9th and the 7th term. So n equals 9, r equals 7 minus 1, which is 6. So we have 9, 6, v to the 9 minus 6, 3 to the 6th. And this should equal 61236 v cubed. And the last one here, number 10. 3a minus 2 to the 7th and the 4th term. So n equals 7, r equals 4 minus 1, which is 3. We got 7, 3, 3a to the 7 minus 3, negative 2 cubed. All right, the fact that this is a negative and this is odd tells us it's going to be negative. And it's going to be 22680, a to the 4th. Because you have to do 3 to the 4th times whatever you get this from here in your calculator. All right, one last thing. The binomial theorem tells us what we've just been doing. The binomial theorem tells us that if, I'm not going to write it all out, it's there in your notes. If n is a natural number, then a plus b to the nth is that. Okay, writing this c and k is the same thing as this that we've been using, same notation. All right, so it says here, use the binomial theorem to expand each binomial. I am not going to do every single one of these, I don't think. Instead of using it's exactly like what we did in the beginning, except instead of using the coefficients from Pascal's triangle, we're going to use this. So we're going to say this equals 6, 0, a to the 6th, 2 to the 0, plus 6, 1, a to the 5th, 2 to the 1, plus 6, 2, a to the 4th, 2 squared, plus 6, 3, a cubed, 2 cubed, plus 6, 4, a squared, 2 to the 4th, plus 6, 5, a to the 1, 2 to the 5th, plus 6, 6, a to the 0, 2 to the 6th. That's a 0. Okay, and then you're going to just do these in your calculator and find out what these numbers are. And here you would get 12a to the 6th plus 12a to the 5th plus 60a to the 4th plus 160a cubed plus 240a squared plus 192a plus 64. And that would be your answer. Okay, same thing for number 12. We've got x minus 3y to the 4th. So this is going to be 40 x to the 4th negative 3y to the 0 plus 41 x cubed negative 3y to the 1 plus 42 x squared negative 3y squared plus 41. No. 3 x to the 1 negative 3y cubed plus 4 x to the 0 negative 3y to the 4th. And simplifying all that, you should get x to the 4th minus 12x cubed y plus 54 x squared y squared minus 108 x y cubed plus 81 y to the 4th. And number 13, oh, there's 2 more. Ooh. All right, number 13, I'm going to give you the answer if you want to do it yourself. I'm not going to write it all out. I mean, I'll write out the answer, but I'm not going to write out the whole problem. You can work on it yourself. All right, that's the answer to number 13. And same with number 14. I'm just going to give you the answer. And then number 15 I will do because it has that fraction. This is 2, 4, 3, n to the 5th plus 1, 6, 2, 0, n to the 4th plus 4, 3, 2, 0, n cubed plus 5, 7, 6, 0, n squared plus 3, 8, 4, 0, n plus 1, 0, 2, 4. All right, let's look at number 15, the last one. 5 over x plus y to the 4th. So that's going to be this. Whoops, wrong way. All right, so let's see what all those are. So this right here becomes 5 to the 4th over x to the 4th. So that is 625 over x to the 4th. And this one, the next one becomes 500y over x cubed. And the next one becomes 150y squared over x squared plus 20y cubed over x plus y to the 4th. And that is the last problem of our chapter and of our year. Oh, so next week we'll just have a study guide and the test, and we'll be done for this year.